Okay, students, we're going to talk about three different uh, concepts here real quick. It should be short and simple. First, called the triangle inequality theorem. It says the sum of any two sides of a triangle must be longer than the third side, which obviously is going to be the longest side. If not, the triangle cannot be created. So there are three examples. 4, 8, and 9. Take the two smallest. The sum of them, 4 plus 8, must be greater than the third side, which is the longest side. 12 is greater than 9, so yes, it can be drawn. 4 plus 8 is less than 13. Remember, it has to be greater than, so it cannot be drawn. And lastly, it cannot equal it either. 4 plus 8 equals 12. So no, it cannot be drawn. It has to be longer than the third side, so this third side must be less than 12. Okay, that's simple to check. Oh, okay. The one piece I forgot in here, I'll add on right now, is if I'm given two sides of a triangle, okay, and they want to find the range for the third side. Example 4. Let's say I have 4, 7, and then blank for the third side. That third side doesn't have to be longer. It could be shorter than these as well. We don't know. We got to find the range. Very simple to find the range. You take the sum of the two numbers, so x, let's call this x right here. Okay, so x has to be less than, remember the two, if x is talking about being the largest, remember the two smallest have to be greater than, so it has to be less than 11. 4 plus 7 adds to 11. Okay, so it has to be less than 11, and it has to be greater than, let's say we want x to be the smallest. Well, then this one plus 4 has to be greater than 7. Okay, so a simple way of doing that is to do 7 minus 4 is 3. So if this was 3, that would also not work. 3 plus 4 adds to 7. Remember, it can't just add to 7 like it can't add to 12 here. It has to be greater than it. So it has to be greater than 3 and less than 11. If these two are the smallest and this is the longest, it cannot equal 11. Remember, the third side has to be less than the sum of the two. So very simply, subtract the 2 and add the 2, and you get your two numbers right here. This is usually a question on the DCAS, so make sure. I've seen this on the DCAS in the past here, so make sure you know this. It'll also be on a quiz and test as well. All right, next, I've seen one of these as well on the DCAS. Ordering sides or angle measures determine which is the smallest to greatest or the greatest to smallest. I just chose to go one direction, largest to smallest for both of them. Okay, obviously you want smallest to largest in reverse order. So if they give you the angle measures, the largest angle right here was created, or this angle created this side right here. Because I open it up here and here for 100 degrees, then when I connect that to that, that was created from this 100-degree angle. So the angle is always matched up with its opposite side. So it says 100 degrees is the largest angle. This is the longest side, BC, segment BC. This is the next largest angle. It would created this side right here. So AC is the second longest. And of course, 20 degrees, because they're all triangles, add to 180. That's the smallest angle, so it created the shortest side, AB, right there. So that's going from the angle measures to the side lengths, and we can go the reverse direction as well. Okay, the longest side has to be opposite the largest angle. Just like this largest angle is opposite the longest side. So 12 is opposite of A, so A has to be the largest angle. 10 is the next longest, so it's opposite of the next largest angle. So C is the second largest angle, and the smallest side goes along with its opposite angle, B being the smallest angle. And that is it. You'll see this on one of your worksheets coming up.